Hi everybody, we're starting a section on inverse functions. Today what I want you to learn from this screencast is how to determine whether a function is one-to-one and how to find a formula for the inverse of a one-to-one function. Those are the two main goals. The first thing we want to start off with is this idea of inverses. What are the properties of inverse functions? Well, first of all is the notation. So if we have some function f of x, its inverse is written f inverse of x. This is not pronounced as f to the negative 1 power. If you see this notation written, what you say is f inverse. So this is f of x and f inverse of x. The domain of f of x is the range of f inverse of x. And the range of f of x is the domain. So the domains and the ranges are switched. The inverse function undoes the f of x function. That's why these domain and ranges are switched. We'll see some examples in the next few slides. Another property of inverses that you want to know is that only one-to-one functions have inverses. The graph of f inverse is the graph of f of x reflected across the line y equals x. And lastly, the composition of the functions is x. So f of f inverse is equal to x and f inverse of f is equal to x. Okay, so here are some examples of inverse functions. So for example, if you're buttoning a shirt, the inverse of that function is unbuttoning a shirt. Another classic example is this machine. Do you recognize it? It's the Enigma machine that was found on the U505 sub. I don't know if you've ever seen that at the Museum of Science and Industry. It's a really cool exhibit. But on that German sub, they found this Enigma machine. And what the machine did is it encoded and decoded secret messages during World War II. That's an example of an inverse function. If you encode a message, then that process of decoding it, figuring out what it's actually saying, is an inverse. So this idea of inverse functions is, like I said before, if the function f does something, f inverse undoes it, and vice versa. Okay, so let's look at some examples of this. So if we have some box, some function box, and what's happening in that box is that we're taking a number, multiplying it by 2, and adding 1 to it. Then the numbers that are going into the box, they're kind of like our domain, right? Those are our input values, and they're going inside the box. So what will come out of the box? What comes out of the box will be our range values or our output. We have input and output. So when we put 3 into the box, 3 times 2 is 6, plus 1 is 7, etc. Okay, now imagine if we had a box that was our inverse function. It's going to undo this function. Then what happens in this inverse function is we're going to go backwards. Instead of multiplying by 2 and then adding 1, we're going to subtract 1 and then divide by 2. This is going to undo that process. So now if I put 7 in the box, well, 7 was the output here, so the input was 3, which is going to end up being the output in the inverse function. So if we put in 7, we subtract 1 is 6. 6 divided by 2 is 3. Same thing with 9. If we plug 9 in, we should get 4 out. 9 minus 1 is 8. 8 divided by 2 is 4. And the same thing with 15. Do you see that idea that we learned about from the properties, that the domain and the range are switched? Here's the domain of f of x, and it actually ends up being the range of f inverse. Kind of cool, right? Okay, the next property has to do with one-to-one functions. So here are some examples of functions. We have a rational function, a cubic function, another cubic function, a quadratic, this is a cubed root, and this is a polynomial function. It looks like it's a fourth degree. So if we're going to check to see which ones of these are one-to-one functions, we're going to use a horizontal line test. You guys are familiar with the vertical line test, right? Remember, these are all functions because every vertical line will only go through the function once. It's the same idea with a horizontal line test, but this time you're going to draw a horizontal line. Is there a horizontal line that will go through the graph more than once? So for which one of these are we one-to-one? One-to-one functions pass both the vertical and the horizontal line test. So this first example is a one-to-one function. Not all rational functions are one-to-one, but this one is. This cubic function is one-to-one. This cubic function is one-to-one. And this cubed root function is one-to-one. So these are the functions that are one-to-one. This one is not one-to-one because there's a horizontal line that we can draw that will go through the graph more than once. No quadratic functions are one-to-one. Notice some cubic functions are. This is cubic, it's not. This is cubic, and it is. And there's no fourth degree function that's going to be one-to-one. No even functions are one-to-one. So anyway, that's the idea behind one-to-one functions. And remember, only one-to-one functions have inverses. Okay, so how do we find a formula for the inverse? Well, here's a procedure. First, you're going to determine that the function is one-to-one. Then you're going to replace f of x with y, interchange x and y, solve for y, and replace y with f inverse. Let's look at an example. So we have this function, f of x is equal to 3x minus 8, and we're asked to find the inverse. First of all, is it one-to-one? Absolutely, it's one-to-one. It's one-to-one because it's the equation of a line. So that's going to be one-to-one. So now we're going to go through this process. We're going to replace f of x with y. So now I wrote y equals 3x minus 8. We're going to switch x and y. So everywhere I see a y, I'm going to write x. And everywhere I see an x, I'm going to write y. And then I'm going to solve this equation for y. So I added 8 to both sides. And now I'm going to divide by 3. So the equation of my inverse function is f inverse of x is equal to x plus 8 over 3. That's the answer. I want to show you these graphs. So the graph of f of x equals 3x minus 8 is this line. The inverse of this function looks like this. It's the line drawn in black. So the blue line is 3x minus 8, and the black line is x plus 8 over 3. Remember that these graphs, because they're inverses of each other, are a reflection over y equals x. So the graph of f inverse is the graph of f of x reflected over y equals x. Imagine folding your paper along that red line, and then the black and the blue lines will meet. Let's look at another example. So f of x is equal to 6 over x minus 2. I didn't do this on the screen, but you should verify on your calculator right now that this is a one-to-one function. It is. You'll see it on the next screen, but you should check to verify that. And since it is a one-to-one function, it has an inverse. So we're going to go through that procedure again, replacing f of x with y, then switching the x and the y terms, and then solving for y. To solve for y here, I'm going to multiply by y minus 2 on both sides. So I have x times y minus 2 equals 6. Since I'm solving for y, I'm going to divide by x, and then I'm going to add 2. So the inverse function is 6 divided by x plus 2. That's the answer. Let's once again look at the graphs. So the graph of 6 over x minus 2 looks like this. It's graphed in blue. And the graph of 6 divided by x plus 2 is graphed in black. And on this third screen, you can see the reflection. You can see that the graphs are reflected over y equals x. The only property we haven't covered so far is this property of the composition of functions. And I want to illustrate this with an example. So if we have some function f of x equals x cubed minus 2, if you plug 2 into this function, you'll get 6. You can find the inverse of this function yourself. It is 1 to 1, and you could find the inverse. The inverse function is the cubed root of x plus 2. And so if I plug 6 into the inverse function, I should get 2, right? That's that whole idea of domain and range and undoing a function. And you can see that works. 6 plus 2 is 8, and the cubed root of 8 is 2. So the question is to find f inverse of f of 2. Well, working from the inside out, what's f of 2 equal to? F of 2 is equal to 6. And what's f inverse of 6? Well, that's equal to 2. That is exactly what this is saying. We don't have to actually know what the equation is. If I ask you and I don't tell you what f and f inverse are, and I just ask, what is f of f inverse of 5? I know by definition this has to be equal to 5. That's how you apply this property. All right, that's it for this screencast. See you next time.